In some of the explanations of how to do things, I've also tried to include why it works so that you understand what's going on and you understand why it's right. However, I think that's been information overload at times, especially in the earlier video on reductios. So rather than explaining why it works, let's just assume that it works and let me explain more on how you do it. Now, though you can do a reductio at any time on anything, the majority of the exercises here are going to have you do them based on the conclusion. What does that mean? It means that we're going to assume that the conclusion is false. This is an argument that's trying to prove it's true. We're just going to assume it's false. I put my line here to indicate that I'm going to make and work on the basis of an assumption, and that assumption is the opposite of the conclusion. Okay, so if I'm assuming that the conclusion is wrong, what am I trying to do now that I've assumed it's false? Well, we're trying to produce a contradiction. A contradiction is anything of this form. It could be based on a single letter, or it could be based on two formulas where on one side of the conjunction it's stated and on the other side of the conjunction it's negated. Either way, but all of these are of this form, and that's what we're trying to produce. Okay, we've assumed the conclusion is false. Based on that assumption, assuming that now that we can use line 4 as if it were true, as if line 4 is true, what can we say? Well, we could say not J, right? Because that follows from the conditional in line 3, our assumption in line 4, and the rule of modus ponens. What else can we say? Well, from the conditional in line 1, we can do a modus tollens now and say that not P is true. And that would follow from line 1 and our assumption there in line 4. Now that we've got not J here in line 5, we could use that with this as a modus tollens and say not P, right? Because we negated the consequent here. That means we can negate the antecedent. The negation of not P is not P. Alright, so from lines 2 and 5, modus tollens. Now this is going to be the last step inside every assumption box of a reductio ad absurdum, and that's this step right here, a conjunction. At some point we're going to have to use the rule of conjunction to combine two things together, and the two things that we're going to combine are something and the negation of that thing, because that just is a contradiction. You've got something and the negation. To produce a conjunction, we use the rule of conjunction. We can combine any two lines. Here I'm going to combine line 6 with the negation of not P, right? So I can now say not P and not P. Contradiction, and it came from line 6 and line 7 by rule of conjunction. Let's see how we're doing so far. Very good, but the proof is incomplete because we just need the last step. When you're doing a reductio, if you can make an assumption and produce a contradiction, then on the very next line you can just plainly state the opposite of what you initially assumed. We assumed not Q, we produced a contradiction, so we can say Q, the opposite of the assumption. In this case, it just happens to be the conclusion, so by saying Q, we've proven that this argument establishes validly that Q is true. So, here's the rule. Lines 4 through 8 are AA for reductio ad absurdum. Congratulations. So, again, the basic steps for these practice problems: assume the conclusion is false, produce something of this form, and then state the opposite of your assumption. And that's a reductio ad absurdum.